Hi, I'm Jim Schwartz, Director of Research Agronomy and PFR here at Beck's Hybrids. Today I want to talk to you a little bit about nitrogen rate and population. Recently, you probably had some folks over for the holidays to eat dinner with you. When you did, you probably had more people than you normally do, and intuitively, you probably made more food for them when they came over to eat. Well, what about corn plants and nitrogen rate? Intuitively, you'd say, as I add more corn plants to my field, I got to provide them more nitrogen. As we go through the data here today, one thing I want you to understand is I'm not telling you this is the absolute right rate for you. Your yield levels may be different. In our practical farm research, we found a level that we find is the right rate for our research, and then we base that as our baseline. Your fields may be different, your yield levels may be different. Also, nitrogen is heavily influenced by soil type and rainfall and environmental factors, so it changes from year to year. But we wanted to dig in and do a little more research on nitrogen rate and population. If you look at this graph, this talks about yield. The red line is yield, and you see yield continues to go up every year. That blue line, though, is nitrogen usage. When you look at that line, you see that in the 80s, it basically flatlined, it stabilized out. Now, the other interesting thing is corn planting populations have also increased during this time. As yield's gone up, so has corn planting populations, yet nitrogen has more or less stabilized. So we wanted to dig into this and discover a little more about why. First, let's look at a couple universities and see what they've found as it relates to nitrogen rate and corn population. So this is Purdue University. This is their data, and what they found is there really is no evidence that higher nitrogen is required as we plant more corn plants out in the field. There wasn't a strong correlation between increasing nitrogen as we increased our planting population on corn. Let's move west. A different soil type, different environment at Iowa. This is Iowa State data. Iowa State basically found the same thing, that the interaction effects of seeding rate and nitrogen weren't really strong. There wasn't really a correlation between, hey, as I add more corn plants, I got to add more nitrogen. So I'm going to show you some PFR data. There's 3 years of data. We actually took a break from doing this study a couple of years. So we'll start in 2016. And if you look, you can see the bars. All right, you can see there's 270 pounds, there's 230 pounds, and then 190. Now, 190 is that rate that in practical farm research over the years, we found that that's our economic optimum nitrogen rate. Now, I didn't say it's the rate that delivers the highest yields necessarily. It's the rate that delivers the highest return for the farm. So in 2016, you can see we have two different hybrids, 5665 and 5829. The 5665, we would describe that more as a nitrogen hog, one that needs more nitrogen and needs it later in the year. 5829, not so much. It's very efficient user of nitrogen, doesn't really require that much nitrogen relative to another hybrid like 5665. When you go through and you look at the different populations, so the green bar is 38,000, the gray bar is 34,000, and then those yellow bars are 30,000. When you look, what you basically see in 2016, we really didn't see a great big response to adding additional nitrogen as we added more corn plants. Well, earlier I mentioned, hey, nitrogen's very fickle. The environment can impact what happens as it relates to nitrogen, so we wanted to be sure we continue to do this research. So in 2017, we did the same thing. So here's a little different way to look at it. This is 5665. Remember, 5665 is a hybrid that needs more nitrogen, needs it later in the year. And you can see the three different populations and the three different rates. Again, we don't see real strong responses to increasing nitrogen as we increased our populations, our seeding rates. What about here's 5828, this is a more stable hybrid, again, not a nitrogen hog, so same year as I just showed you. You can see, same thing, no real strong response to increasing nitrogen as we increased our corn plant populations in 2017. Now fast forward to 2020, we skipped a couple years of doing the research, and then we picked this back up in 2020. So we've got a couple different hybrids there again, and I've shaded, you can see the gray bar would show that at the different population, what was the most economical nitrogen rate. And for the most part, there were a couple of exceptions, but for the most part, again, when you look at all three of those locations, all those populations, that 190 pound rate seemed to be about the right rate. A couple of ear shots I thought would be interesting to share with you. These are this is from Henderson, Kentucky, some ears that we pulled. Just thought if you look, there's the three different populations and the different nitrogen rates. You don't really see visually, you don't see great big differences. All right, here's a different hybrid, same location. a little bit of difference, but you don't see, visually, you did not see big differences as it related to increasing nitrogen as we increase population. So what's the 3-year data say? Here's what it tells us. When you look at 30,000, 34,000, and 38,000, economically, the base rate that we have found over the years is the most economic rate for us is 190. And when you look at our data, it really does not pay to increase nitrogen as it relates strictly to population. Now again, one thing I want to be clear about, there may be years when you have a lot of rain in season, you're going to need to add more nitrogen. That's not really what we're talking about. This study was basically designed to look at and say, necessarily as I increase my seeding rates, do I need to increase my nitrogen? Our data, 3-year data, multi-location data would say, no, not really. And when you look at the university data we shared at Purdue and Iowa State, it would agree. But now the question is why? Because that doesn't make more sense. I talked earlier about when I have folks over for dinner, I make more food to feed them, right? Well, why is that? Is that because nitrogen's not the limiting factor? No, in a lot of years, I think nitrogen probably can be a limiting factor. So I don't necessarily think that's the answer. Is it because we've improved our timing, our placement? We've done a better job stabilizing nitrogen? Yeah, I think that's a part of it. We'll talk about that in a little bit. But the one big driver that I think we tend not to focus on, or maybe we tend to overlook a little bit, is mineralization of organic nitrogen. Okay, we really don't think about that when we think about nitrogen. I think we need to start thinking about nitrogen. So I'm going to spend a few minutes now talking to you about what is mineralization. Well, mineralization is the burning of organic matter contained in your soils. So your organic matter has as part of its construct a number of items, and one of those items is nutrients. And so when that organic matter is burned, it basically releases those nutrients into the soil and makes them available to your plant. Now, mineralization is a biological process, and it's dependent on a number of environmental factors. So think about that. Anything that can impact a biological process can impact and drive mineralization faster or slower. Let's take a minute and talk about some of those environmental factors that can determine whether or not mineralization goes quicker or slower. So the first one is temperature. Warm temperatures drive mineralization faster. Cool temperatures drive it slower. So if you have warmer spring, better soil temperatures, that will drive mineralization quicker. Another factor, of course, is oxygen. I mean, fires burn hotter when they are supplied with oxygen. Same thing with mineralization of organic matter in your soil. The more oxygen, the more mineralization, the more you burn that organic matter, and you burn it quicker. Okay, so that's really important. Both oxygen and temperature have a great impact on mineralization in your soil and release of nutrients, including nitrogen. Now think of an example where you have really cold temperatures and you don't have a lot of oxygen. Well, think about a peat bog, right? Now think about the organic matter in a peat bog. It's very high. Why? Because there's no oxygen and it's very cold. And so over time, organic matter accumulates instead of burns. And so you have those high organic matter pockets. Think about muck pockets in your field. Where are those spots? They're typically lower, colder depressions in a field. The reason is they typically hold more water in their colder areas, and so they don't mineralize nearly as quickly as the rest of the part of your field. What about moisture? Well, proper moisture is required in order to mineralize your soil. Too much is a bad thing. Think about that peat bog, right? And not having enough also. In a really, really dry year, you won't mineralize nearly the amount of organic matter as you will when you have very good moisture levels. Here's a great example, I think, when we think about mineralization. Every year you go and you watch Fox News or your local news show, or you read online where you'll see they've found a shipwreck from the 1700s at the bottom of the ocean. And when they go down and look at it, it looks pristine. It looks like it was sunk the day before. Well, why is that? And these are wooden ships, right? Why have they not just fallen apart down at the bottom of the ocean? Because there's no oxygen down there to drive that mineralization. Now think about it too. What happens to that ship when they bring it up out of the ocean? What do they do to it very, very quickly? They submerge it back either in a preservation solution or they get it right back in water, because if they expose that wooden boat to air, it'll fall apart very, very quickly from the oxygen and the mineralization. Same thing applies in your soils. What about pH? It's a little less well-defined than these other factors, but we know that if you have very high or very low pHs, really acid, really alkaline soils, that will impact the amount of mineralization that goes on in your soils. And then cultural factors also can impact mineralization. If you have very tight clays and they're very compacted, how much oxygen is going to get in those soils? Not nearly as much, and they'll remain wetter. So a lot of the cultural factors that we employ can drive mineralization. So why don't you think about an area of the country here in the United States where we have warm temperatures pretty much year-round, and typically they have good moisture year-round. Right? I typically think about the southeast United States, and when you drive down through Georgia and other parts of the world like that where they have good moisture levels and warm temperatures, what do the soils look like? Typically they're more orange, they're weathered, right? They don't have the organic matter because it's been burned over and over and over again. Think about dealing with residue, right? If you're in Tennessee and you have corn residue, what happens to that residue over the winter versus, say, Minnesota? Minnesota, residue is an issue, right? Because they have their winters set in so quickly, it's really hard to break down residue because it's so cold so quickly. Whereas Tennessee, that residue can break down very quickly. Same thing applies to your soils. Now, we started talking about nitrogen rates and how does that impact relative to plant populations. So I want to get back now and say, what is, as you think about, what's the key takeaway as I think about mineralization? Well, in order to do that, we need to do math. I don't like math, but I think it's important to talk a little bit of math so you can understand the numbers behind it, and you can actually do this calculation at home. So let's start with this. Start with an acre furrow slice, okay? That's basically it's 7 inches of soil. So if I take the top 7 inches of your field and I pull 1 whole acre out, all right, a great big slice of it, that weighs 2 million pounds. Right? That, by the way, is when you think about soil tests, right? If you have parts per million, they tell you to do what? They tell you to multiply it by 2 to get pounds per acre. That's why, because that acre furrow slice weighs 2 million pounds. The other thing that's really important to understand is organic matter is about 5% nitrogen. Okay, so your soils, depending on the level of organic matter, but every percent of organic matter is comprised of about 5% nitrogen. So let's go through some math to help understand why we may not need to add nitrogen necessarily as we increase our planting populations. All right, I talked about that 2 million acre furrow slice. I'm going to use an example and just say it's 1% organic matter. For simplicity, I don't like to do math, so I'm going to keep it really simple. So if I have 1% organic matter soils, and that top acre furrow slice is 2 million pounds, that means that 1% organic matter weighs 20,000 pounds, okay? That 1% of organic matter in that acre furrow slice weighs 20,000 pounds. Now, earlier I said organic matter is about 5% nitrogen. So if you take that 20,000 pounds of that 1% organic matter and you multiply it by 5%, then what's that mean? That means if I had a 1% soil, I got about 1,000 pounds of organic nitrogen in the construct of that organic matter, okay? Now, if every year we mineralize around 1 to 3% of the organic matter in our soil, some years, depending on temperature and oxygen and pH and moisture and things like that, it may be more like 3 or 3.5%. Some years, if it's hot and dry or cold and wet, we have very compacted soils, that number may be much lower. Maybe it's down at 1%. So let's say for our example today that I have a pretty good year and I mineralize 2% of the organic matter in my soil. Well, if 1%, so I'm talking about a 1% organic matter soil now, I have 1,000 pounds of organic nitrogen. If I mineralize 2%, then that means my soil, my organic matter, is giving me 20 pounds of nitrogen, all right? If I have a year where I have really good mineralization, maybe it gives me 30 pounds of nitrogen. Now, keep this in mind, though, as I talked about that, I was saying I had 1% organic matter soils. What if I have a 3% organic matter soil and I get 3% mineralization? Then I'm going to get around 90 pounds of free nitrogen for every, basically, 1 acre furrow slice. And that's the thing I think we might be missing as we start thinking about mineralization, right? A lot of the crop models that exist today really don't calculate mineralization much above that 3%. Why? They're only thinking about that 1 acre furrow slice. That's all they think about when they give credit for mineralization. So that's why I really think we need to consider what's going on in our fields. I share this picture with you. You can see there's a drip tape in that picture. That drip tape is down at about 16 or 17 inches, all right? Now this is more of a prairie soil from Illinois. When you look at those roots, and if that drip tape's down at 16 inches, let's say, And I just talked about 7 inches of soils. Here's my question for you. Do you believe that we might be mineralizing at that next acre furrow slice? I'm convinced that we are. Now, we're not mineralizing at the same rate. We're not mineralizing as much, but there is mineralization going on down in that 2nd acre furrow slice. But remember, models don't calculate that. A lot of folks out there don't give us any credit for that 2nd acre furrow slice. I want to show you some data. It's from the University of Illinois. This was a study they did, and it was actually, they were studying different nitrogen application methods. But here's what I think was really, really interesting. When you look at this data, in the fall, they went in and put on nitrogen, and then they came back, and what they did was they measured at 2 feet depth, okay, 2 feet depth. So they put on 200 pounds in the fall on the 3 bars on the right. On the left, on the 2 bars, I'm sorry, 4 bars on the right. On the 2 bars on the left, they put on 175 pounds of N. Then they came back and measured in mid-April. So mid-April, probably not the warmest soils yet, so not a lot of mineralization. And they measured in the top 2 feet the amount of nitrate nitrogen and then ammonia nitrogen. So look at the numbers. Let's look at Warren County there, for instance. They put on 200 pounds of nitrogen in the fall. How much nitrogen did they find in April? 300 pounds of nitrogen, right? You can see there's a lot of mineralization going on. Now, you're not going to get that 100 pounds in mid-April simply from mineralizing that top acre furrow slice. It's coming from other depths as well. So that's why I think it's really important as you start thinking about this data, to start thinking about how much mineralization am I getting? So here's some more data from Illinois. Monmouth is in west central Illinois. So they went and measured the unfertilized check on June 7th. Now, June 7th, we've probably got a little more mineralization going, right? Warmer soils, these are good organic matter soils. The unfertilized check had 167 pounds of nitrogen on June 7th. They had 9 sites in Sangamon County, all right, where they put on 225 pounds in the fall. It went back and measured on June 2nd, found 363 pounds of available nitrogen on June 2nd. And then if you look in Champaign County, where they put 190 pounds in the fall, they came back, found 279 pounds. So here's what I'm saying, all right, as we wrap a little bit of this up and we start thinking about this. As you think about adding planting population to your corn plants, okay? If you add more corn plants out there, there's this natural thought that I've got to increase my nitrogen. What I think we need to start considering is that my soils and the ability that they have to provide free nitrogen via mineralization of organic matter is probably greater than we've been giving them credit for. Now, again, the thing you have to consider is that may vary from year to year. It'll vary from soil type. It'll vary based on your cultural practices. But we are mineralizing probably more nitrogen at greater depths than we've probably given ourselves credit for. Now, the other thing we talked about was how about timing and placement? Can that influence the total amount of nitrogen I may need? And I think it does. So what we did this spring in Practical Farm Research, we went out 2 different growing stages, and we basically laid these boards across the row. And then we pulled soil cores, multiple locations across that row, and then we took those bags, so multiple locations in the field, took those bags and sent them in and said, hey, tell us where is the nitrogen? So when we're talking about placement, so here's a smaller plant. We did it at 4 weeks and 8 weeks. Here's the 4 week. The prior slide was the 8 week sample, okay? So where is that nitrogen? We think about not only giving credit for mineralization, but what about placement? Well, here's what our data showed us, okay? So the green line on top, that's actually nitrate nitrogen. Ammonium nitrogen. The gray line is the nitrate nitrogen. So when you look, basically there's corn row on the left, corn row on the right, and then each one of those holes, what you're seeing is the results of where that nitrogen is. So where is the nitrogen in the row 4 weeks after application? It's right in the middle of the row. Where are your corn roots? They're not over there, not at 4 weeks after application. Okay, that's great. Let's go back and let's look then at 8 weeks. When we pulled those samples after 8 weeks, here's what the data shows us. So each one of those where it says 3 inches, 6 inches, those are actually the holes in the ground. All right, and then as you see, now you see that we do have more nitrate, which makes sense, right? Because that ammonium's been converted to nitrate. But the vast majority of that nitrogen is still in the middle of the row. That's why one of the things that I think we're doing better as we start thinking about nitrogen and nitrogen programs, we're doing a better job with placement. We've got guys who are banding more. A lot of guys are using Y-drop. So they're being more efficient and effective with their nitrogen application methods. So we've tested this in practical farm research. We're also testing this bar where they're putting some in the middle, some next to the row. So we're testing a lot of those different things to say, hey, does timing matter? Does placement matter? Do stabilizers matter? And the answer is yes. Bottom line, as you start thinking about nitrogen as it relates to plant population, our data would show, all things being equal, simply comparing those two factors, not talking about your soil, your organic matter, the growing season itself. As you think about it, as you increase your plant populations, at least from 30,000 to 38,000, our data would show you don't necessarily have to add more nitrogen in order to get the top economic return on your fields. It's just not necessary. Data from Purdue and data from Iowa State would kind of validate that you don't have to start pouring more nitrogen, at least up to that 38,000 plant population. You don't have to add more nitrogen simply because you increase your planting population. Thanks for joining us today. Have a great day.